As we start looking at the interstellar material, I want to give you a little preview of three different types of nebulas that we're going to encounter. So on the left-hand side we have emission nebulas. In the center we have these reflection nebulas. And on the right-hand side we have what I'll just call interstellar dust. Alright, and so we're going to take a look at the three of these, but to really understand these we need to understand some things about light itself. So remember back about how we get emission of light from atoms, right? So on the top you see a case where this is a hydrogen atom, right? And an electron can get excited somehow, right? So that electron moves up to a higher energy level. Then that electron will spontaneously decay downward, and when it does that, it gives off some light of a very particular wavelength, right? And so this is what's happening inside these emission nebulas. Let's take a look at this a second, right? So the key here is that there has to be some form of energy coming into the atom, something that's giving the energy to the electrons so they can then emit. So here's this beautiful example of an emission nebula. This is the Rosette Nebula, which is the same nebula you saw in the beginning of our lesson. You see it looks very different. This is more like its true color, right? It's really mostly red. The picture you saw at the start had several different colors in it, which was due to using different filters, right, to make it look different colors. You're seeing different parts of it. So this is mostly red, and the question I just want to emphasize with you is where's the energy coming from, right? So there has to be something that's giving the gas this energy, and that something is the stars in the center. These are really hot stars, they're new stars, and so you can almost see that they're kind of blowing the gas outward, like you see this bubble forming, right? So that's pouring out tons of energy, a lot of it in ultraviolet, and that's exciting the electrons in this in these atoms, right? So they get excited and then they spontaneously decay and they're giving off this red light. So this is what we call this an emission nebula, right? It's an emission spectrum that's coming out of here, where the hydrogen atoms are emitting at a very specific wavelength of light. They're beautiful. They're mostly red because it's mostly hydrogen gas, and so they emit in this red light. Now I want to talk for just a second with you about dust, because dust influences a lot of these nebulas in other ways as well. And this is a microscopic picture, right, of what a dust particle looks like what an interstellar dust particle would really look like. So you can see it's incredibly small, and it's these tiny grains that are kind of stuck together, but it's 0.02 millimeters across. So these are really tiny. Now, dust particles like this exist here on Earth as well, right? I mean, it's not like the dust bunnies in the corner of a house, but they exist in our atmosphere, that we have dust. And what's interesting is this dust scatters light. But it scatters light in an interesting way. It scatters blue light much more than it scatters red light. So take this picture of the sun, for example, which I happen to take. That's why I'm using this picture. I think it's a pretty picture. But here at sunset, the sun looks really yellow and reddish, right? And the idea there is that the blue light that's normally also coming with the sunlight is being scattered away. The dust particles in our atmosphere tend to scatter the blue light the most. The same is true of interstellar dust particles. They scatter blue light the most. So the red light can sort of penetrate through. And that's why we see the sun kind of turn red at night. The sunlight is passing through more and more layers of the atmosphere, right? It's kind of like thicker towards the horizon, right? And so it looks even redder than when it's straight overhead. Now the same effect is what causes the sky to look blue during the daytime, right? When we're not looking directly at the sun, when we're looking at the sky, we're seeing blue light. And that's that blue light that has been scattered in all directions, right? So our sky looks blue because of this dust and these particles that are in our atmosphere that are scattering that blue light in all directions. Now, we see the same thing up in the sky, right? So the red light penetrates through the dust, right? And so let's take a look at this. This is an example of a dust cloud deep in space, and you can see that it blocks a lot of the light, right? You just don't see it, right? So you can see this big dust cloud, but notice around the edges of the cloud how the stars that clearly would be white you can see that they're whitish stars. They look kind of red, right? It's almost like they're setting behind this cloud, right? So they're turning kind of red. Of course, towards the center of the cloud, not even the red light is red enough to penetrate through that dust cloud, right? Even the red light is getting scattered away or absorbed, so we can't see it. So if we had light that was even redder than red, it might be able to penetrate through, right, and not get scattered. Well, we do have light that's redder than red. It's called infrared. And so if you look at the same cloud in the infrared, you can actually see the stars behind it. It almost looks transparent. It's still being kind of reddened a little bit, right? Like we're still seeing some scattering even of the infrared light. But you can see that the red light is passing through. Right? So we're seeing that same analogy where the dust is scattering the blue light away and the red light's passing through. Now let's see if we can see that blue light that's being scattered. Well, there are these nebulas that are called reflection nebulas. There's an example here on the left called the Pleiades. Right? And so here these don't look red, they look blue. And what's happening here is the light, what we're seeing is the scattered light off of these clouds, where instead of the red light passing through it, the light is sort of scattering away, and we're seeing the blue that's sort of left over, right? And so the same process happens both in our atmosphere and in these interstellar clouds. Okay, so I just wanted to give you a quick preview of what we're going to be seeing in this lesson and what you're going to be reading about in the textbook.